Okay. Now, the Earth rotates about its axis at constant period time of 24 hours. What torque keeps it spinning? Come on, think and answer. Earth is rotating, no? So, who is applying the torque to the Earth? Think, draw sun, Earth, and all, and see. Rotating about its axis. They didn't say revolution.
Sir, no torque.
No torque.
Correct, no torque.
Yes.
Even the Hemant is in active state. Very good. Be happy like this.
Yes.
Very good. There will be no torque. Okay, because it is in a state of see, it is rotating. It started rotating, so it is continuously rotating by itself. So it is conserving its angular momentum.
Angular momentum, yes.
Okay, that's it. Okay. Okay, fine.
Yes,
Right. So now you know, all of you have played with the top.
Yes, sir.
Bagri. All of you have played.
Yes, sir. Yes, sir. Yes, sir.
Girls are not telling yes, sir.
Yes, sir.
Yes, Purti, Vaibhavi, Vaishnavi. ಏನು ಬಾಯಿಲೆ ನಿಮ್ಗೆ ಬಗ್ರಿ ಆಟ ಆಡಿರಿಲ್ಲ
Yes, sir.
ಆಗಿದೆ so bagri aad when you play it you know it will be rotating rotating after some time it will do like this and it will fall. I hope you have noticed that.
Yes, sir.
ಅವಾಗ ನಾವೆಲ್ಲ ಇದ್ದಾಗ ಗಿರ್ಕಿ ಹೊಡಾಕತ್ತಿದ್ಲೆ we used to tell that ಗಿರ್ಕಿ ಹೊಡಾಕತ್ತಿದ್ಲೆ we used to tell. Okay. Okay, consider two cases of a top rotating upright with constant angular velocity initially.
Yes.
Pressing at constant angular speed. Pressing means hinga tirkonta hinga tirಕೊಳ್ಳೋದು pressing ಅಂತಾರೆ.
Yes, sir.
Discuss the equilibrium of the top in two cases with respect to the contact. Did you get the idea?
Yes, sir.
Yes, sir. Yes, sir.
Everybody there?
Yes, sir.
Sir, please explain it.
ಇವ ಬಗ್ರಿ ಅಡಿಲೋ
Arrange.
ಈಗ ನೋಡಿ ಅದಕ್ಕೆ ನಿಮ್ ಚಿತ್ರ ತಗೊಂಬಂದೇನು ಬಗ್ರಿ ಇದು ದುರ್ರ ತಿರುಗಿಬೇಕಾದ್ರೆ ನಾಟಕ ತಿರುಗಾಗತ್ತೆ ನೋಡಿ ಈಗೇನಂತ ಬಿಡಕ್ ಸ್ಟಾರ್ಟ್ ಆದ ಯಾವ ಅಂತ so when it is see it is rotating and this axis itself is rotating.
Yes, sir.
The top is spinning about this axis and this axis itself is rotating.
Yes, sir.
About this point.
Yes.
So this is what we say it is pressing, P-R-E-C-E-S-S-I-N-G, pressing about this point.
Yes, sir. Yes, sir.
Okay, now answer this. So consider the two top cases. When it is rotating upright at constant angular velocity, okay, and at constant angular velocity and pressing at constant angular speed. Discuss the equilibrium. So when it is rotating upright at constant angular velocity, is it in equilibrium?
Yes, sir.
Both rotational and translation.
Yes, sir. Yes, sir.
Both rotation and translation? Yes.
Both, sir. Yes, sir.
But when it is pressing,
No, sir.
No, sir.
Direction is changed.
Direction of angular
then
momentum.
there is still change. It is not.
Yes, sir.
Correct
Yes,
now?
sir.
Yes. Good.
Then what is the driving force?
You only tell what is the driving force. You got the ಗಿರ್ಕಿ ಹೊಡ್ಯಾಕ what is the driving force? What are the forces acting on it? ಅದೇ ಸೌಕಾಶದಲ್ಲಿ ಇಲ್ಲ ಯಾರು ಹುಡುಗಿ ಹೆಸರು ಕೇಳಿದ್ರಿ ನೀ ಹೆಂಡತಿ ಹೆಸರು ಕೇಳಿದ್ರಿ ಯಾಕೆ ಕಾಣ್ತೀವಿ ಅಂತ ಅದನ್ನ ಕೇಳಿದ್ರಿ ಸರ್ 10 ಬಾಯಲ್ಲಿ ಓದಕ್ಕೆ ನೆಟ್ಟಿಬೇಕು it's my weight vector man. It's weight vector.
Perpendicular to the angular momentum.
Wait.
See man, now you see now where is the weight vector? The weight vector is passing through the axis. So the weight vector is balanced by the normal reaction. So what is going to cause the torque? Nothing is going to.
Yes.
Now it is bent. Now the weight vector through the center of gravity is here.
Yes.
Yes, sir. Yes, sir.
And the normal is here.
Yes.
So normal is like this, weight vector is like this.
Yes, sir.
Understand? So that will cause a torque.
Yes,
Yes, sir.
Understand? That will cause the torque.
Yes, sir.
And that is why that this one will start rotating.
Sir, they are given
Yes, sir.
constant angular speed. Then only direction.
Angular speed is constant.
Yes, sir.
This is angular speed is constant. But this axis you see,
It is changing.
axis is changing. So angular momentum is what? Angular momentum is what? The omega must be constant.
Yes, sir.
Omega must be constant means what? See, now the omega vector, if the top is rotating, then the omega vector is like this. Now the omega vector is changing its direction.
Yes, sir.
So angular momentum is changing.
Yes, sir.
Understand? Direction is changing, so it is changing.
Sir, the magnitude of angular momentum is same, sir. Then we can conclude that weight force is acting perpendicular to the direction.
That all next thing. Yes. Same thing. What we did with the conical pendulum, similar situation. I'll show you. Did you all get it, friends?
Yes,
Yes, sir.
Now you see better diagram. So you can see omega is up here, mg is down, n is down, and omega is also along the same axis. So top is in rotational equilibrium. Tau
Yes, sir.
O is 0. Tau about this point is 0.
Yes, sir. Sir, once we start spinning it, sir, and it, in this case, no, sir, which you are showing just now, so, sir, slowly the circle goes on getting wider and wider, sir.
Which circle?
Why like that, sir?
At the node, ile node. It's next second diagram node. So now what happened here? Mg is down, n is up.
Yes,
But
sir.
omega is along the axis. So this axis you see, this axis is rotating. Can you see here?
yes, sir.
Yes,
That is
sir.
what we call it as pressing. And that is happening because mg and n, they will create a torque.
Yes, sir.
And because of that torque, okay, see the torque, it is like this. So the torque is acting perpendicular to this two axis. Can you see here? Perpendicular to omega axis and the axis of rotation.
Yes, sir.
And therefore it starts moving like this.
Yes, sir.
Okay, so it is not in a state of rotational equilibrium.
Sir, when the magnitude of mg and the magnitude of n, sir, they are not changing, then why should like the circle go on getting wider, sir?
Circle is getting wider.
Yes, sir.
See, now here what is happening is, there is something here happening here, okay? There is friction here. There is friction at this point, and there is also a drag friction. So
Yes,
frankly
sir.
speaking, what is happening is omega is decreasing.
Yes, sir.
Okay, omega is also decreasing, and that is why all these things are happening.
Okay, sir. Okay, sir.
Sir, how gravity affects the rate?
See, now let's see on this top now, on this top now,
Yes.
one force is this and another force is mg. Okay, about this
Yes.
point. So this force n and mg, there are two forces acting at two different points of the same object, and they are anti-parallel. So what happens? You will get a torque in this direction.
I said that I can use.
Correct. Hello gentlemen. This is omega vector. Okay.
Yes.
And torque vector is what? Torque vector is out of the board.
Out of the board.
So you have got omega vector like this and torque vector pointing towards you.
Okay. Sir.
And this torque vector pointing towards you will bend the omega vector towards you.
Yes, sir. Yes, sir. Yes. Understand. Sir.
Thank you. Got it?
Yes, sir. Yes, sir.
Yes, sir. Study outwards.
Yeah.
Conical pendulum.
Conical pendulum also. Similar. Okay, that's what. It's a genuine question. If you have doubt, you ask. See, this is a very interesting chapter, but difficult. Difficult at your age. Okay, but you all have to take it as a challenge. Come on. When the going gets tough, that tough get going. But if you start thinking, oh, I'm not understanding, I was very, very blessed in my school, I was a topper in my school, now I'm not a topper in the college, I'm not understanding, somebody else is understanding, then you will go to doubts. And that's why I told, before you all enrolled in my classes, I told, if you have come here to learn, then this is the right place for all of you. But if you have come here to say, I want to get into IIT, I want to get into NEET, I want best ranks, then this is not the place. I'm telling you. You are here to learn. Just learn nicely. Okay, then getting into IIT, getting good ranks and all will be a consequence. But if you are now putting pressure on yourself, oh, I should get into it, I should get into it. Oh, he is answering better, I am not able to answer. Oh, he is following things, I am not following. Then you are putting pressure on yourself and curtailing your learning capacity. So just enjoy learning. The nature will take care. Understand? That should be the focus. And if you are good students, you will always try to become good learners. But if you are bad student, then you will only worry about all the marks. He is answering, I am not answering, I am not understanding. All this nonsense, will be in your head. So just throw all this trash out of your head. Only concentrate on learning. Don't worry about your future. Till you write your final examination, don't worry about your future. After you write your final exam next year, then we shall think about your future. Now your job is only to learn, not to think about anything other than learning. Okay, fine. Will you solve this problem? Aram se. 10 kg uniform rod OA is pivoted at O in a vertical wall with the help of a cable AB. Understood now? The rod. And it is pivoted here. Pivoted as a. If you cut this thread, this rod will fall off. So this rod is held up by this thread.
Yes, sir.
And in life, they have made it simple by showing the tension in the thread is like this. And the weight vector is down like this.
Yes, sir.
But the reaction here at the pivot, they have shown it by R. You know? Right?
Yes.
Sir, it should have been along that rod.
Yes, sir.
Allay irud gammat. Yes. Who will tell this reaction vector is right or wrong?
That's correct, sir.
It is correct. See, sir, that rod, no. For that rod, one force is weight down.
Yes.
Other force, this thread, is pulling the rod like this. It's pushing it to the wall.
Yes, sir. Yes, sir.
So the forces acting on the rod. What are the forces acting on the rod? The forces acting on the rod is this and this.
Okay.
And so the resultant is this.
Yes.
Resultant of all this. Okay. But the reaction will be equal and opposite. Therefore, this point is in a state of equilibrium.
Yes, sir.
Okay, it's a genuine doubt. Fine. So the reaction force is like this, these two forces. So nice. Find the tension in the cable and the reaction force applied by the pivot. Come on, do it. This angle take it to 30 degrees. So basic rule you follow. Now you have three vectors. They are asking you this tension and this reaction. Follow the basic rule. Life will become jingalang. So what is the basic rule you will follow? You resolve this into components. T by and T. And this is W. Then this is Rx. And this is Rx. And this is Ry. Result. Now it becomes equal. So Ty will be equal to T sin theta, and Tx will be equal to T cos theta. And W they have told is how much? 40 kg. That is 400 newtons.
10 kg.
10 kg. 10 kg. Okay. So this will be 100 newtons. That's all. So you cannot do it. So Ry plus Ty will be equal to W, and Rx will be equal to Tx. So this is 100 newtons. So there are 1, 2, and 3 unknowns and only 2 equations. So
So we can write it out.
wait.
Talk about it.
So you can get the third equation by taking the torque.
Yes, sir.
Now torque you take about say this point. So if you take about this point, then this Rx and Ry will get eliminated. Okay,
Yes, sir.
will get eliminated. So here the torque about this point will be what? So W into L by 2.
Yes.
W into L by 2
Is equal to
will be is equal to
T1
Ty into L.
Yes, sir. And
So you will get the relations.
tension is
Good. ಏನು ಇವತ್ತ ಖುಷಿಲೇ ಬಂದಿ ಇವತ್ತ ಕಾಲೇಜ್ ಒಳಗೆ ಫುಲ್
No, it's not.
ಬಾರಿ ಕಾಲೇಜ್ ಒಳಗೆ ಕಾಲೇಜ್ ಸ್ಟಾರ್ಟ್ ಆಗೈತಲ್ಲ ಇವತ್ತು ಆಗ್ತೈತೆ ಭಾಳ ದಿವಸ ಭಾಳ ಮಂದಿ ನೋಡೋಣ ಇಲ್ಲ ನೋಡಿ ಖುಷಿ ಪ್ರತ್ಯೂಷ್ ಫುಲ್ ಫುಲ್ ಸ್ವಿಂಗ್
Even without considering the topic, we can do.
ಹೆಂಗೋ ಹೆಂಗ್ ಮಾಡ್ತೀವೋ ರಜಾ
Said the Rx equals to Tx.
Rx equal to Tx ಮುಂದೆ
So said R sin 30 will be equal to T cos 30. We'll get relations and
but then you don't know this theta no here. Hey, Anna, only this theta is given, this theta is not given. This we don't know. You cannot assume it is 30 at all. Okay?
yes.
If that was given, then life would have been jingle. Okay, shall we proceed, students?
Yes, sir. Yes, sir.
Yes, sir.
So did you get R is equal to 100 newtons?
Yes, sir. Both are
Both are
100.
Yes.
Yes, sir.
Both are 100. So today Dimath is getting answer,
Yes.
Arun is getting, everybody is getting. Good. Now see, the saga will start. Everybody will get. Okay. See, trust me. This chapter very important, but very difficult. So somehow you try to learn as much as possible in this chapter. Somehow.
Yes, sir.
Everybody will avoid this chapter. I've seen most of the teachers because they are afraid of teaching this chapter. If you teach this chapter, what the student might think teacher doesn't know how to teach, or student himself might become mansik. Or student chalo ಮಾಡ್ತಿರ್ತಾನೆ RBD ತಿಳಲ್ಲ ಅನ್ಕೊಂಡು ಮಾನಸಿಕ ಆಗ್ಬಿಡುತ್ತೆ. So that is why everybody is afraid of this. But I am not like that. I feel when the going gets tough, the tough get going. Because I have trained myself in many sports, especially mountaineering. So mountain, yes. So when you would see a mountain, oh fine, I will also climb. So all Ghosh and Josh. So you start climbing. So halfway through you will start feeling, because by the time you go halfway, to keep one leg, one foot leg, like lift and keep, you will think 100 times, oh, should I keep or no, and how should I keep? Huh? And your body will be sweating. You would have been fatigued. But now no going back. You can't go back. You have to climb. But somehow then your trainer will say nothing to it, you have to climb. So somehow who crooked, you will try hard and you will climb. You will really be cursing yourself, why did I do this and all. But once you overcome that hurdle and you reach the top, nothing like that. You will feel so energetic, so fantastic. This chapter is like this. So even if you understand 50%, don't worry. You will start getting confidence in everything, physics, chemistry, maths. So I believe in that, and I am sure all of you accept the challenge. That is why you are sitting here. Okay, in best of the coaching institute, what they also, that is why they will filter toppers. So in each batch, 1 or 2 students they will take, and they will take them separately, and for such students only they will teach, because they will tell others cannot absorb it. But I don't believe it. Okay, I say every student has got the capacity to learn, and he will learn. And last year, you see, the 2 of the students who cracked IIT, they were like you only, many of you. They were, RBD, like this. But their spirits was very good. So they did it. Nobody expected that they will do, but they did it. Because they were good students. Why I call them, and they were strong students. Why I say strong? Because they were trying to learn. That is why I say they are strong students. Not that they were solving sums. Oh, some students solve sums, they are very good. No, in my category, no. If they are hard learners, then they are really strong students.
Yes.
That should be the focus. And sulla grip ಮಾಡೋದು, ಮನೆಗೆ ಹೋಗಿ ಅಪ್ಪ ಅವಾಗ ಅಳುದು, ನಂಗೆ ಟಫ್ ಆಗಕತ್ತೈತಿ, ನಂಗೆ IIT ಆಗ್ತಿದ್ದಿಲ್ಲ. Then start seeing all the YouTubes, so many coaching classes. Okay, then you will go to docs. Don't do anything like that. Just do what I will tell. You don't go and see any YouTube and all. Okay, whatever time you have got, you just do, take the module and work and concentrate in the class, right? And enjoy these subs.
Yes,
Don't try to get answers. Enjoy. Ice cream tingo. Solve it. This is L/4. Sorry. Uniform rod of 20 kg hanging. Okay, in horizontal position with that of 2 jets, it supports 40 kg mass. Find the tension developed in each thread. Very simple problem. Solve. Tension A, tension B. If some of you are very good, you solve it orally without using pen and paper.
Yes, sir. Yes, sir.
You also got the same answer? TV
Yes,
200,
sir.
TA 400.
Yes, sir.
Others also do. Aram se do. See, you should draw properly, Dhiman. You have not done the drawing. Leave it. You see, if you do like that, you will stumble. Why are you? Be cool. See what is there. I have just whatever is given, you just represent. See whatever is given there, TA, TB. Tension here, and 440 kg is hung here at a distance L by 4, and the weight of the rod is 200, 20 kg, 200. So just show the fact. First is, see, that's what you don't try to do anything how, don't try to become intelligent and all. Whatever the data they have given, you just put it. Then you cautiously convert it into a mathematical framework. What is it? Now, if you take the moment about this one, why did I check moment about this point? See, this number I know, this number I know, this distance I know, this I don't know, this I don't know. So if I take the moment about this point, then I can forego TA. So then I take the moment about this, because at the moment you look at the diagram, the inspection, it will tell you this force and this force will turn the rod like this, and this force will turn the rod like this. So this moment must be equal to this moment. So what is this? 400 into L by 4. Moment of this about this point, plus 200 into L by 2. Okay, so and this must be equal to TB into L. So L's will go. So then manipulation here. So here you see this is 400 L by 4. I will take the same LCM. So therefore taking the same LCM is I will multiply and divide by 2. So I get here 400 by 4. 400 by 4 is equal to TB. So 400 by 4, 400 by 2 is equal to TB, or TB is equal to 200.
Sir, even there was another thread attached to the 40 kg.
That will be 0 because we are taking from point A.
What did you say?
There is tension in another thread, no, so that.
What have you got? That tension itself is 400. What will that tension? See, that tension in this thread, the tension in this thread itself is 400 Newton.
It will be acting in the upward direction.
What is acting in upward direction?
Sir, if that for that 40 kg, sir, the thread which is holding that 40 kg.
Why are you working on the? Sir, where you work on the rod? You work on the rod. What are the forces acting on the rod? You see, man. Why you want to see what is the force acting on the body? They have asked you to get TA and TB. That's all. So you work on the rod. Why are you bothered about the body then? Why are you bothered about the body? You see, you are unnecessary putting. See, don't put pressure on yourself. Okay, examinations will come. Let it come. Aram se, be aram se. Just write the diagram. You have to now see that this beam is balanced. So see what are the forces acting on the rod. FBD. FBD is what? Forces acting on the body. So FBD for this you should consider. Why should you consider FBD for the body? Wait. Don't have to consider.
Okay.
Then you get this. Then once you know TB, then TA is simple. Okay, done. Everybody got it?
Yes, sir. Yes, sir. Got it, sir.
Hi, somebody. Hi, yes. Ha.
Sir, there 200 into L by 2, sir. Sir, we should consider the distance from the center of mass, sir.
No, center of mass of this, sir. The rod is
Sir,
basically.
when 40 kg of some force is acting, sir, then won't the center of mass shift?
No. See, gentlemen. Now there is rod. What is the center of mass? See, what is it now? You have got a rod. Okay. Now this rod is one entity. This rod is one entity. So this rod will be replaced by its rod center of mass is here, and the weight of the rod you must put it at the center of mass. In fact, it is center of gravity. So you should put the weight vector at the center of gravity. Okay, then the weight of the rod is taken care of.
Yes, sir.
That is what I have done. See, what you add to the rod will not change its center of gravity.
Okay, sir.
Huh? Okay, shall we proceed to the next problem?
Yes, sir.
Hmm. 400 and 200. Okay. 400 and 200. Okay? Done.